All right, welcome to section 1.5, modeling and accuracy. So in this section, we're going to look at how we can use mathematics to create models for real world situations. So our first vocabulary word here, math models, is basically just going to be an equation that we create or that's given to us that corresponds to something in the real world. So a lot of times in math, you work with equations with X and Y, and they don't have anything to do with something tangible or real. We're just manipulating variables and numbers. But the end goal for mathematics is to create math models that actually tie into something in the real world. And they allow us to compare or quantify or understand more about what's happening and report that information to other people usually. So two examples of math models. One of them is for the area of a rectangle, length times width. So and a concept that you can have is what is the surface area of this rectangle? And if you know the length and the width of the rectangle, you can create a model that helps you understand the area. And that model is just simply area is length times width. So when you think of a math model, basically all the equations and formulas that you've learned are examples of math models. They can be very simple, like formulas for area, or in this case, the second example here, 2 pi r is the circumference of a circle. So the distance around the perimeter of a circle, if we have a radius r. These are just easy examples, but they could be way, way more complex. Like say you own a business and you're creating a model for your revenue or your income based on the number of stores that you have opened and what month it is and the cost of your supply chain and all this kind of stuff. So they can be really, really robust and complicated, or they can be super simple. But these are math models, that are equations that we create to help understand something in the real world. Okay, our second topic is accuracy. So when you are creating your math models, you need data, you need information from the world to plug in to create these models. And when you collect information through measurement, it's not going to be perfect. So whenever you're actually measuring something in the real world, there's some amount of uncertainty in that measurement. And so accuracy is the second vocabulary word here. Accuracy measures how close you are to the actual or desired value. So anytime you try to measure something, say you're using a ruler or a watch or a clock to measure how long something lasts, there's a little bit of error in that measurement. Did you start it at exactly the right time and end at exactly the right time? What were the increments on the measuring device that you used? Are you measuring to the nearest centimeter, to the nearest inch, to the nearest micrometer? So how good our data is determines how accurate our model is. So if we have a more precise measuring device, then we're going to get more accurate results with our measurements, and then our model's going to be a lot better. And let's just read through this together real quick. So accuracy refers to how close the measured value is to the actual or desired value. And math models typically require real world data, so measurements, to develop. When we make these measurements and we collect this data, we have to consider how good the data is. How much accuracy you need depends on what you're doing. So rough estimates are going to have lower accuracy. And for example, parts that you design for a mission to Mars are going to require super high accuracy, which means the measuring tools that you use to collect that data are going to have to be really, really high quality. So let's just do two quick examples to understand whether or not we need high accuracy or not, and what we could use to achieve these results. So if you're measuring how tall you are, it's not a life or death situation. If you're off by 1/2 inch, it's probably not that big of a deal. So how tall you are does not really require high accuracy. And so you can use something like a meter stick or a tape measure or something like that that just marked, every 1/2 inch or every 1/8 of an inch or something like that. And if you're off by a little bit, if you measure yourself to be a 1/4 inch too tall or too short, it's not probably going to be a big deal. Another example in the opposite situation would be, what dose should we use for the COVID-19 vaccine? Well, this is extremely, extremely important to get the right dose, because if you use too little, it might not provide you with immunity. But if you use too much, there might be some side effects or some negative consequences. And so the dose here of the COVID-19 vaccine is something that they're going to have to collect a lot of data about and then measure very, very precisely, right? You don't want them to accidentally give you 2 milliliters of the vaccine when you're only supposed to get 1 milliliter of the vaccine. That would be really, really bad. So the models that we create require data to be collected. The data that we collect has a range of accuracies possible, both in terms of how we collect it and what we need for the model that we're creating. But collectively, all of this is kind of a step back and looking at math and saying, what do we actually want to accomplish with mathematics? Is it just symbol manipulation, or can we apply it to help ourselves out in the real world? And so thinking about math models and thinking about the accuracy of our measurements helps us see how we can apply math to make our lives better. Okay, that's it. I will see you guys in class or for the next video.